Today we're going to take a look at Job Control's material database. What is the material database? The material database is all our preset saved settings for all the materials that we're working with. We can save them so that they're easily accessible when we're working with a specific material. I've got a job set up here in CorelDRAW, and I'm going to print the job to the laser. During the print process, I'll be able to access the material database, and I'll show you how to do that from within CorelDRAW. I have a picture on the screen here. It doesn't really matter what we're going to be using here. I'm going to go File, Print, and you'll see the print dialog box come up. I've got the Trotec engraver print driver selected. I'm going to go to Preferences. This allows me to access the preferences for the print driver that we're going to be using, which in this case is the Trotec laser. To access the material database, I'm going to come over and click on this little icon here, which is under the material settings. And I'm going to have the material database accessible now for me to use. Before we talk about the material database, let's just take a look at a process flow that typically we suggest for people that are running a laser machine. As you can see from the standard setting here, I've got black color is engraving and the red color is cutting. And typically this is what we suggest that people set their jobs up as. It's not a hard rule that everybody has to follow, but it's a rule that we suggest because typically when we train people, this is what we're going to ask them to do. If somebody sends me a file to check out, typically it's a lot easier when they're making the engraving black and the red cutting. And if you're calling tech support, it's definitely a lot easier when everybody's working on the same page and they assume that you're working with a black color for engraving and a red color for cutting. The rest of the colors are normally reserved for different colors of vectors. We can have different colors for engraving too, and we'll talk about that in this video. Before we go on, let me just make a comment on these default presets that are actually provided in the driver. One thing I've told people over and over for years and years and years is that when the manufacturer provides presets, they're based on what they feel a product should look like. They're not necessarily what you might think that they should look like. So take a look at these settings as suggestions, as starting points for you. For example, if I look at the solid wood setting, they've got an all their black setting in here. Now, a lot of people may not know what they mean by all their black. The fact that they've got a Z offset at 0.25 says to me that they're trying to make the engraving blacker. And again, that may not give you any depth. So again, you may take a look at this and say, I like this setting, and maybe I'm going to run it at 100 power, and maybe I'm going to run it at 30 speed because that's what I like the look to be. And again, that's up to you, and that's why we always tell people that you should be practicing, you should be experimenting, and don't be afraid to change these settings because what we put here isn't necessarily what you want or maybe even what your customer wants. So don't be afraid to experiment with these. We'll take a look at another video down the road that we'll talk a little bit more about how to experiment. But again, typically what I do is I tell people to use these as starting points, but don't necessarily use them as stone. Make sure that what you're getting is what you want. And if it is, then you can make the changes and save them so that whenever you're using the product, the material, then your settings will be set properly. If we take a look at the material database, you notice we have two main windows here. The window on the left holds all our materials. In this case, this is the default setup that the driver loaded in. On the right is all the settings for each one of those materials. We'll go through each one in depth. On the left is our material settings. During the install, there are a number of default material settings that are actually loaded with the driver. These are listed here right now. I haven't added anything into this material settings yet. So this is basically what you would get if you installed the driver by default. This setup looks typically like a folder structure that you would probably see in Windows Explorer, where we have folders and we have materials. For example, Delrin is a folder, and then inside Delrin we have one material setting or one folder or one file. If you click on the minus, that will contract the folder back up. If we click on the plus symbol, that will expand it out. Again, if I select one of the materials, then we will actually have the material settings listed on the right-hand side, along with, in this case, a description and the material thickness. If we look at leather, again, we have one material setting here. If we look at paper, we have 4. And again, as I select the materials, you'll notice that the value will change for each one of those materials. If we right-click on plastics, you notice that we can create a group, we can create a material, we can cut, copy, which are standard functions you'll see in Windows. We can rename, or we can delete. Now, if I right-click on here and I create a material under paper, let's say we're going to call it PETG. Again, I just type in my text, press enter, and now I have a new material setting under plastics. Now notice that there's no settings here because we really don't know what the settings are, so it's going to give you basically a default setup that has no power, speeds, or any settings within the actual material setting. We'll need to place those all in manually after the fact. If we don't like that, we can right-click on it again, and we can rename it. So we can call it PETG Plastic. Or we could actually right-click on it and delete it. If we wanted to, we could actually create a subfolder here. So if we select plastics and then we right-click, we can create an actual group. So we could actually have an acrylic group under a folder under here, and then under the acrylic, we could then come in and say create a material, and we could say 6mm acrylic. And notice here, if I right-click back on this, I can't create any more groups. So really all I can do is a nested group inside a group. I can do more materials, but I can't do any more folders. So if I right-click on here and I go delete, and I right-click on here and go again and I go delete, I've lost my material and my subfolder. What about if we want to put a whole new folder in the top level structure here? That's easy to do. We're going to bring our window down by pressing the down arrow here, and we're going to place our cursor on the blank area below the last folder, which in this case is called wood. I'm going to right click on here, and I'm going to say create group. And you notice it goes up to the top, and we could call this acrylic, say we didn't want it under plastic. So now I have a top level folder, and then under there I can right click on here and I can say create a material and call it 6mm acrylic. And again, you might want to come back here and then delete this and save these plastics for anything that's non-acrylic, and then put all your acrylics under here. So really all we're doing here is just sort of categorizing things, trying to keep them as clean as we can so we don't have a whole bunch of materials on here and it's harder for us to find them. It's easier for us to load these in whenever we need them. You'll also notice that I have some icons down here that I can actually click on to create a material group or create a material. Again, these only work for selected folder. So if I select acrylic and I go, I want a new group, then I can create a new group in here. And, you know, this could be cast. And if I want, I can create a material group under here. So let's call that, you know, 3mm. And again, I didn't spell this, so let's right click on this and let's rename this and let's put an A in there. And you'll notice here that I can't create another folder, as I pointed out earlier when I was right clicking on this. I can create another material group, but I'm done for creating nested folders. If we look at the bottom left-hand corner, you'll notice that there's a gear here with a down arrow. Again, if I click the down arrow, it expands out, and you'll notice that I have some more commands inside this configuration menu. Export all allows me to export the whole database out. Always a good idea to keep an offsite backup of your material database. You typically don't want to leave everything on the one computer in case the hard drive goes down, or if if you have a fire or somebody steals the laptop or the PC, then you lose all your material settings. It's always good to have a backup that's kept somewhere, either on the cloud or on another computer, or better still, even off-site. So if I go export all, then I can actually export out, and we'll just call it all materials. Save. And you notice that I now have a file called allmaterials.xml. If I want, I can import that file in. I'm down to all materials, double click, and I have the ability now to bring in all the materials to support. So again, you can select import materials and override existing ones, import materials and create a copy of an equal material names. So again, you may want to keep the one that you created, the one you changed, but you want to bring one of the old ones back in. So again, you can have a copied version if you want, or again, you can import all the materials and override all the existing ones. Below that is export a selected material. So again, if you want to just save certain materials, then you can say export selected material, and I can come in here and we can call this lead glass. You notice here that I have that one selected, so that's the one I'm going to call it. So save. Now if I delete out the lead glass, you see it's 40 and 100. Let's get rid of that one. Delete. And let's go in here to import. And let's come down. And we can say lead glass. Open. And again, I want to import material and override existing ones. And you'll notice that the lead glass comes back in again. So again, very important to make sure that you do have those backups there just in case there is a catastrophic failure on the computer, or pray tell somebody overwrites the actual existing settings and you have to go back to testing again because maybe you can't remember what you used before. Under our configuration menu here, you also have a view setting. And here we can show the parameter information for the column. So if we click on this, you'll notice that we get another column that shows up to the left of our process setups here. Again, this is really just another area that we can put some helpful hints in here for the materials or the process that we're working with. So we might say, for black, we might say that this is wood. And we might say that this is the inside cut. And we might say that this is the outside cut. Again, there may be some other things that you may want to put in here, but again, this helps out when you're bringing the material in, and again, it makes it easier for you to remember things. It makes it easier for your operators so that they know that anything red is going to be an inside cut, and they know that anything that's blue is going to be an outside cut. So again, very helpful if you want a descriptive text in there to help you show the process or the material that you're working with based on that color. Again, if you come back down here to view, we can turn that back off by just clicking here, and again, it's gone. The down arrow is saying color ordering. sometimes you may want maybe blue to go before red. Right now you'll notice that if I decide to make my red cut and then my blue cut, then the way the driver processes this is all the red's going to get done first and then the blue's going to get done second. We may want the blue to go first. Well, right now I have no ability to do that. This is locked in and can't be changed. However, if I hit the down arrow and I go to color ordering, I can make the color order changeable. So what I can do now is I can take the blue and I can move it above the red. So now blue is working before red. You notice over here I've done a color change order, which gives us a little bit more of an explanation of what's going on. Now again, if I'm done doing this, I can actually come back and I can drag this down. So now the blue is here. I could actually move this one up, and again that blue there could go first. You'll also notice in here under the color ordering, I can reset materials back so that they're where they're supposed to be. So again, I can come back in here, and if I uncheck this, now there's no ability anymore to move this. If we look under the gear icon, you'll notice that we have locking. What locking allows us to do is to actually lock out the material database so that materials can't be changed or deleted. Definitely, this is very important if you have operators, because a lot of times they may be going in, they may not be as familiar with the software, and they may make changes to the material database and not realize that they're doing it. So again, the beauty of this is that it locks everything out and allows nobody to change things or delete things. So if I come in, let's set a master password first. So let's call it test. So now we have a master password set up, which is test. You notice that we're in min mode. Now min mode allows me to make changes to the database or to delete things or include things. If I want, I can come in here and I can say locking, and I can say lock all, which will lock out the whole database. Now I can still make changes to the database because I'm in min mode. However, if I say OK and I exit out and I come back into the material setting and I go to here, if I try to make it, you'll notice that it doesn't say in min mode anymore. So if I try to make a change here, I can't make a change. If I come over here to delete this, I can't delete it either. I can create a material, I can copy a material, but I can't delete anything, and I can't change the existing materials that are there. If I hit the gear icon down, I can switch to admin mode. So if I want to make some changes, I can come back in here and I can say test and log back in again. I'm in admin mode. This allows me to make my change. I can say OK. If I come back in again, you notice that I'm out of admin mode, and again, I can't make any changes. If I go back to admin mode again, type in test, I can unlock everything. And let's say I want to lock just a certain material. I can right click on it and say lock. Now if I exit out of here and I come back in again, you notice now that I can't delete this out, and I can't change anything because that material is locked out. Come back, switch to admin mode, and if I want, I can reset the master password. That will delete the master password, and I'm starting from scratch again. There we go. Now that we've talked about the material settings folder structure on the left, let's take a look at the actual settings themselves, and let's talk about those. As I mentioned earlier, again, we have engrave is black in this setup here for our standard setting, and you notice that red is cut. Okay, so for most people, when the laser is moving back and forth and it's creating an image, normally that's what we call engraving. Anytime the machine is working in sort of a plotter motion, then that's cutting. Okay. First of all, let's talk about power and speed. The way the laser machine works is you actually have a sort of power such as a light bulb, where you've got like a 60 watt or 100 watt or 120 watts. The laser machine works basically the same way. When you purchase a machine, you're going to get a rated laser tube that could be 60 watts, it could be 80 watts, it could be 120 watts, it could be 30 watts. And basically what that means is that tube will put out as a total 30 watts of power or 80 watts, depending on which tube that you buy. Now, what you can do is you can actually adjust both the power of that tube. Here, right now I'm saying 50, which is 50% of the actual power. So theoretically, if I had, say, a 60 watt machine, I'm only running at 30 watts when I say 50, because that's 50% of 60. So it's a linear type equation, you know, whereas as you lower the power down, the percentage down, the power goes down. Okay. And you notice here that, again, it's adjustable anywhere from 0 or up to 100. Now, speed works the same way in terms of percentages, where 0 is no speed and 100 is the highest speed. And again, speed and power work together. So if I'm running 100% power, let's assume we're 100% power here, and let's say I'm doing some wood engraving, and I look at the wood and I'm going, it's just not deep enough for me. So I have two options. Let's say, for example, that I need double the depth. So what I would do is I would slow the machine down to 50. That means that I'm now traversing twice as long over the existing spot that I'm creating, and I'm getting more depth. I could also put in a second pass over here, and again, I can it's the same thing as putting in the 50% here. So it's always important for most people and me included, is normally I want to go as fast as I can. So normally what I'm going to do is I'm always going to run my speed at 100, and I'm going to adjust my power accordingly to go along with that speed. If I'm running at 100 and I notice that I don't have enough power, my only option is to start slowing the machine down. And when you slow the machine down, typically what you're doing is you're sort of causing less productivity in your operation, which is why it's important that you always buy, you know, as much power as you can to be able to go as fast as you can. You know, these machines go at 140 inches a second, so you know, we don't want to, you know, hold them back. We want them to be able to traverse at that speed. So, but we do need the power accordingly to go along with that speed. You know, the analogy I always use is it's like touching an element on a stove. If you touch it very quickly, then you really don't feel anything. But if you leave your finger there for a couple of seconds, then you get burned. And speed is the same way. If I go really, really fast, it's almost like just rapidly touching the element, so I really don't feel anything. But if I put it down to 30 speed, then now I'm going a lot slower, and I have a lot more power that's being placed on that spot, and therefore I'll get more power. And in case of wood, I'll get more depth, and the thermark will get better bonding by the material. So again, there's always a trade-off between power and speed to allow us to get the appropriate mark. And cutting works basically the same way. The only difference really is that a lot of times with cutting is that I have to move at a lot slower speed. Typically, very rarely, you know, do you see, you know, a speed, depends on the wattage, but you really see a speed over 4 or 5%. Because the machine, again, runs so fast, you need the appropriate amount of power to be able to cut through that material.
Next to power and speed is PPI in hertz. PPI stands for pulses per inch, and this is typically controlled by the resolution of the printed image that we send from CorelDRAW. So if you go file print from, say, CorelDRAW to the laser machine, in the print setup, it'll ask you for a printing resolution that you want to use. Typically, I use 500 dpi. And what this means is that we have 500 dots going left to right, and we have 500 dots going north to south in a 1-inch box. Now, if we want a little bit more burning left to right, then we can actually increase this number, say, to 1,000. And the rule of thumb really is try to stay double. So in this case, 500 times 2 is 1,000. And what this will do is it will give me more pulsing in the X direction. I'll have 500 rows going down. So changing this number doesn't increase the time of the actual engraving. It just gives us a little bit more pulsing in the X direction. If I click on the auto, then what the auto will do is just pick up whatever the printing resolution is. In this case, if I sent over 500, it'll pick up 500. The hertz stands for the pulses per second by the laser machine. In this case here, I'm pulsing at 2,000 pulses per second. The lowest number I can get here is 1,000. And typically what I suggest on this is when we're cutting wood or paper or cardstock, something where I need a really high peak power, then typically I'll use 1,000. On things like acrylic, typically I'll move this back up to maybe 3,000 to 5,000. And this will pulse a little bit more. Our peak power will be a little bit less, but we'll get a little bit better melting edge on our material.
The passes setting here basically allows me to increase the number of passes. So for example, sometimes when you're engraving thick materials, or if you want to engrave deep into material, like if you're doing a 3D relief image, normally you don't want to go at one pass because you do a lot of burning. Normally you want to go at 3 or 4 passes. Well, this allows us to type 4 in here, and the machine will go over 4 times and then process the red next. Again, sometimes you might use that in cutting because, again, 2 lighter cuts are better maybe than 1 heavy cut in terms of issues on the amount of discoloration or burning that happens on the cutting. The air assist allows me to turn this on or off for most of the machines. Some of the machines have the ability to have extra gases used, so that's what gas 1 and 2 are, but for the most part, most of the machines are running either on or off. Normally for engraving, we normally have this off because what happens is if I'm shooting air down onto the cutting surface, I'm actually defeating the purpose of the actual vaporization of that material. So normally I leave it off. Again, very important to make sure that you do have a good airflow for the exhaust, because that will allow less dust to accumulate on the lens. So the air assist there sometimes is there to protect. So if we're working with something that's really, really dusty, you may want the air assist to be on to help keep the lens clean. Normally I find I like to keep it off. And again, that's something that you can play around with a little bit. On cutting, I normally have it on all the time, depending on what materials I'm doing. You can turn it off, but for the most part, we keep it on. I like to keep it on. It keeps the flame down, gets rid of the dust and the residue that generates inside the actual cutting curve. So again, the ability to turn it on and off here. Nice thing about this is that the air only comes on when you tell it to come on. So I don't have to have a pump going all the time while it's engraving and having it blow the air off. All I have it come on is when I actually need it, which in this case is the cutting of the red. The Z offset is to allow me to my table to move in between colors. A lot of times, if you watch my plastic video, you'll notice that I'll engrave out of focus, and then when I go to cut, want to be back in focus. So I might, I'm normally going to have maybe the material go out of focus, maybe 90 thou. And then when I go to cut, the table's going to come back to focus, which that's what the 0,0 is for.
A couple of other uses for the Z offset would typically be if, say, we were doing, say, a wood item that had 2 different levels. And the Z offset works really well for this. So we could, say, send over part of the job in black, and we could laser engrave the job at a certain Z height, and then let's say on the job there was another level where we actually had to move the table so that it became in focus. So then we'd send that part of the job in red, and then what we would do is we would set our offset in the red to compensate for whatever the height is. So let's say it's 1/2 inch, so we could put in 0.5 inches, and that will drop the table down. Minus number goes up and the positive number goes down. So again, what will happen here is that the job will engrave in focus. So we would set our focus to 0 for the black, and then once we got to the red part, then the table will actually drop down 1/2 inch. Another situation that I've used the Z offset would be, let's say for example, engraving a bowl with high sides. Once the engraving's done inside the bowl, if the head was to go back to the home position, it would hit the sides of the bowl. So we need to drop the table down to clear that side. And the way we do that normally is we'll focus for the normal engraving, and then we'll engrave that in black. Then what I'll do is I'll place a small rectangle in the job with 0 power and force the machine to move, and then it'll do the little circle or the square, whatever we've designed, and then when it goes back home, it'll clear the side. There is a couple of other ways to get around that in job control, but sometimes this works really well. The Z offset's a great feature because it allows us to control the movement of the table while we're actually working with the laser machine. The only thing to remember on the Z offset is it can only move before we engrave a color. So we can't move as we're engraving the black or the red or the blue. It will actually have to move, then do the engraving, and then move again, and then do the engraving. So we can't have an active movement like we would say on a CNC machine where we've got Z-axis control and we're sort of doing a relief style cut. The last column we have is the advanced column. Right now it's set to default. If you click the down arrow, you'll notice that I have some commands underneath the default setting here. The correction value is the first one. The correction value can be applied to both raster and vector images. And really what it's doing is it allows us to apply a little bit more power to either the cut or the raster image as we slow down. A good example of this in a raster image would be if we were doing, say, a photograph or a logo on black anodized aluminum. And as we traverse across the table left to right, as we come to our edges, a lot of times what would happen in the old days would be the engraving would fade out on the outside edges. The correction value allows us to apply a higher value if we need to apply more power to that outside edge. So if I'm engraving black anodized aluminum and I'm finding that my image is fading out on the edges, then I may take it from 10% to maybe 30% or maybe 20% to test it out. Again, this value can go right up to 100, and typically you can adjust this. A lot of times I'm typically only working between 0 and 30. It just really depends on the materials that you're working with. When it comes to vectors, typically where we use this a lot is if we're going into a corner and we have to stop, turn, and come back the other way. What happens is we're saying basically as we get into that corner, keep the power at 10% and then turn and come back. If you notice that you're getting either overburning or maybe you're cutting material and it won't separate from the corners, then you'll need to adjust this setting. If you find that maybe the piece isn't coming out, then maybe you want to increase the value. If you find that you're overburning on the edge, then maybe you want to decrease the value. The links setting here allows us to put a tab periodically through our job. Easiest example I can use typically with most people is I say, remember the balsa model airplanes we used to get, and they all had a tab on it. You'd have to kind of, fold them back and forth to get them to break away from the main piece of wood. Links typically has been used in the rubber stamp production, where we would have an 8.5 by 11 and all the rubber would engrave and then cut, and you'd have a little bit of a tab there. Allowed you to take the full sheet out, clean it, and then easily separate them out. The high quality mode is something that we've used in the engraving of Lamicoid materials, and typically in this area where we use this is if you're using, say you've got a job and you've got maybe a descending character or an ascending character, and the background of the plastic that's been engraved looks different than the main body. And this is just due to the ramping of the laser machine. It's an issue we've had for forever, and again, there's a setting in here to solve that problem. And what we're doing here is we're just forcing the laser machine to go the full length of the text or logo that we're working with. And what that does is that it evens out the background, so that even though the ascending character has shorter strokes, we're forcing it to go all the way across the main body, so that the ascending background, in the background of the ascending character, looks exactly like the background of the main body. This typically makes the engraving longer, but it's a trade-off so that you can get a more consistent background. A lot of times, if you use your Z offset and you go out of focus when you're engraving plastic, then this is not as noticeable. But again, it's there to help out. The raster correction, we typically use that for photographs, and typically if I'm doing photographs, I will click this on. The last command here is the IPC command. This stands for the Intelligent Path Control, and basically right now I've got it off. However, if I want, I can optimize the speed of the laser, or I can work on with the accuracy. Again, this is something you may want to play around a little bit with. Don't use it too much, because a lot of times we're cutting thicker materials, so we really don't get a lot of speed. But again, this might be something advantageous if you were cutting, say, fabric or thin papers, and you may be able to speed the machine up a little bit more, and maybe trade off a little bit of accuracy with speed. So again, it's something that needs to be played around with. Within the materials database, you'll notice at the top here I have a thickness and a description. The thickness can help us out in a couple of ways. First of all, it can tell us the thickness of the material that we're working on. In this case, it's 1/8 inch, or if we were in millimeters, that would be 3 millimeters. This is typically used for a visual representation or a visual cue for us, so we know what we're working with, but it's also used for the autofocus from within the software, from within job control itself. What happens here basically is you can just click the autofocus, and the machine will automatically focus to this thickness of material, based on whether you just have the solid table or whether you have the grid table in your machine. Again, I caution, this is for an advanced user, and you can get yourself into a bit of trouble if you're not careful when you are working with the autofocus. So again, it's something that we suggest that if you are going to use it, that you make sure that you're a relatively experienced user, and you may want to get some direction on using it. The description area here just allows us to put something in that's descriptive of the material that we're working with. For example, maybe I'm working with 0.125 cast acrylic from Trotec, and maybe in bold letters you might want to see, make sure you take off the plastic cover if engraving. We've all done this before, and again, it could be something that maybe it's something you may want to put in here to help the operator as a reminder for what they're doing. So again, helpful couple of areas here. One for the thickness of the material we're working with, and one for the description that we can place in here for the material that we're working with. Before I end this discussion on the material database, I'd just like to point out that there are a couple of different areas that you can access the material database other than the print setting from, say, a program like CorelDRAW or Illustrator. Once the job's in on our desktop here, you'll notice that if I go up to settings, I can go to material template setup, which is the hotkey is Control-M, and this allows me to get into the material database and make any changes that I want after I printed the job. This is quite important in case I need to adjust power and speed settings. Once I bring the job in, I don't have to resend it over again. Again, you can also double click on a blank space. So if I double click over here, you'll notice my job is here. Turn off the WYSIWYG here. So if I double click here, I also get access to the material database. Just remember that if you double click on the actual image of your job, you'll get a print preview, and we'll get a lot of people that'll call up thinking something's gone wrong, because as you look down here, you can see that the USB icon is grayed out, which means that I can't connect to the laser machine, and if it was connected, I couldn't send a job over. All you really need to do is just press escape. It's probably the easiest way to get out of the print preview.